Hi, this is just a quick movie showing you how you can align your image stacks using AutoQuant. We can get misalignment in stacks due to things like vibrations, stage movement, faulty filter cubes, etc. And we're just going to show you here how you can do a simple procedure to correct for that alignment. So firstly, let's take a look at this image stack. I'm just going to play through it, the Z stack, and we can see here that it's really jumping around, it's all over the place. So I'm actually going to show you how to perform a slice to slice alignment here, and that basically is going to correct for XY movement between slices in the Z direction. So these slices which are jumping around should appear relatively stable. Okay, so I go to the slice to slice shortcut here. Firstly, I'm going to just use the recommended expert settings, making the alignment both in X and Y direction, and launch and see what we get. Okay, so here's the aligned image. Okay, firstly, let's just compare maximum intensity projections here. Now we can see clearly on this aligned image on the right, we've got a much better projection here. This is a bit of a nonsense projection, really. That's caused by the images being so badly aligned. We couldn't get a good maximum projection. Okay, now if I compare slices and synchronize both these sets, we should be able to play through and just see how good the alignment's been. Okay, so looking here on the left, we can see how much it's jumping around, and if we look at the aligned image now, it's really a lot better. It's a lot more static. We can look at these lines here and we can see they're pretty well aligned. They're still wobbling a little bit. Okay, so the alignment could be better, but that's a pretty good improvement, really. Okay, but let's see if we can just make the alignment that little bit better. So I'm going to go back to my original unaligned image. I'm going to go back to slice alignment here, and I'm just going to have a look at some of these expert settings now. So by default, it's given us an image warp severity of none. Okay, now this is the option that allows you to select for corrections in warping as well, i.e. if you think your image may have been not only moved in the XY but also warped, distorted, we can correct for that. So by default it gave us none. I'm actually going to say normal here. I think there may have been some warping in this image. Alignment method it's given us here, compare to nearest slice. This is an alignment method which takes each slice and compares it to its neighbours and performs the alignment based on that. Okay. Actually we may be better off using an adaptive method here. This basically looks at every slice in the stack and decides which one has the best cohesion with the other ones, which one is the all-round best aligned one, and then it bases the alignment of all the other slices compared to that slice. Okay. Void region fill. This is a little aesthetic option, really. As we see here, in an aligned stack, we're going to get parts of the image that have no data, and what we're going to represent there. Actually, we had random selected, so you can see we just got random values here. For fluorescent images, I tend to think that black is the best to use. It's a personal preference, really, but we're going to go with black this time anyway, and perform the alignment. Okay, and here we go. So let's compare our newly aligned stack to the original. Okay. So we see how much the original jumps around, and here's our newly aligned stack, and actually it looks a lot better. We can see we've got the black borders here. We can crop this a little bit out if we want to get rid of those, but also you can see that it's not a straight line anymore. These are curved lines compared to the first alignment we did, and that's because we're considering warping now. So it's not only moved each slice in an XY direction, it's also considered warping. So if I actually compare my first alignment based on the default settings with the second alignment, we should be able to notice the difference here. Okay, so first alignment here on the left is pretty good, but we can see it wobbling around a little bit here. My second alignment here, these lines here really are looking static, and it really looks like a much better alignment. Okay, so that's slice to slice alignment. there is another way that we can align images, and that's based on the channel-to-channel alignment. Okay, so it's the same principle really, but instead of looking at individual slices, single channel, comparing the XY movement between slices, we're actually looking at a multi-channel image now, and aligning the channels. Okay, so we've got 3 channels in this image. We could align this using an automatic base slice. Okay, this is allowing the program to recognize which slice it's going to use automatically. That's the recommended setting. You can choose your own slice if you like. So we've got 62 here, but we're going to ask it to automatically set the slice there. And again, we have the expert settings, which are the same as the slice-to-slice alignment here. So we want warping correction, not really in this image, our alignment method, and the void region fill. Okay, so it's a pretty similar basis. This just works well for multi-channel sets. Okay, so we launch that. We can see in our new set here, we can actually see it's looking a little bit different. This image really didn't need aligning particularly. We can see it's obviously aligned the channels a little bit better now, and it's changed the colours because the co-localization is going to be a little bit different now that the channels are better aligned. Okay, well, I hope you found that helpful. For more information, please contact your local sales office or dealer. Thanks.